Okay, so today in Algebra 2, we're going to do the first part of Section 7.5, graphing other trig functions. Today we're going to focus on graphing the tangent and the cotangent, okay? So we're going to use what we know about the unit circle to create a table of values to help us graph the tangent function. It gave us parts of the unit circle over here. So we're going to go from x's from negative pi over 2. We're going to go, let's say pi over 2. Negative pi over 3, negative pi over 4, negative pi over 6, 0, and then we're going to do the positive ones, pi over 6, pi over 4, pi over 3, and pi over 2. Okay. If I start here at 0, okay, and remember that tangent is equal to the sine over the cosine. So if I start at 0, okay, when x is 0, okay, when my radian degree is 0, the sine is 1. Sorry, the sine is 0, the cosine is 1. So this is 0 over 1, 0. I go to pi over 6, the sine is 1/2, the cosine is square root of 3 over 2. So 1/2 divided by the square root of 3 over 2. We flip and multiply by 2 square roots of 3. Our 2's cancel. We have to rationalize. And so we end up with the square root of 3 over 3. Pi over 4, the sine is square root of 2 over 2. The cosine is square root of 2 over 2. So when I divide that by itself, I get 1. At pi over 3, square root of 3/2 over 1/2. And when I flip and multiply 1/2, everything cancels except the square root of 3. At pi over 2, the sine is 1, the cosine is 0. 1 over 0 is undefined. So I know all of my pi over 2's are going to be undefined. Negative pi over 3 is going to be negative square root of 3. Negative pi over 4 is going to be negative 1. Negative pi over 6 is going to be negative square root of 3 over 3. So we see that the graph of y equals tangent of x goes through one complete cycle. Okay, so I start at undefined, and I go negative square root of 3, negative 1, negative square root of 3 over 3, 0, square root of 3 over 3, 1, square root of 3 to undefined. So I do one complete cycle from negative pi over 2 to pi over 2. Over that interval, the range is negative infinity to infinity. The boundaries of this interval, y equals tangent of x, okay, so notice that the boundaries of this interval, y equals tangent of x, is undefined. These are the values where the cosine of x is equal to 0. Since tangent of x equals sine x over cosine of x, anytime the cosine is 0 and we're trying to divide by 0, it's going to be undefined. Therefore, the graph y equals tangent of x will have vertical asymptotes at these values, okay? So I know that all of my pi over 2's are vertical asymptotes. So I'm going to draw those in here. So every pi over 2 is going to be a vertical asymptote. So now if I plot these other points, so 0, we're at 0. So this I can go ahead and label, okay, halfway between 0 and pi over 2, this is pi over 4. This is negative pi over 4. This is 1, 2, 3, negative 1, negative 2, negative 3. So at pi over 4, the tangent was 1. Negative pi over 4 was negative 1. We know that we're going to get very close to our asymptotes, but not touch across. So the tangent, it looks like this funny little S. So again, I know all of this, the same pattern here. So this is what our tangent function looks like. We discovered this in our graphing calculator lab yesterday. So now let's talk about the features. The domain will be all real numbers except for the odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, all of those we will have vertical asymptotes. The range, negative infinity to infinity, I can have any y value. The period of the tangent function is pi. The zeros, wherever the sine of x is equal to 0, I will have zeros. So 0, pi, 2 pi, 3 pi. Vertical asymptotes at my odd multiples, pi over 2. Where is our graph increasing? So from left to right, where is it getting bigger? Everywhere. Where is it decreasing? This graph never decreases. Where is it positive? When it's above the x-axis. Where is it negative? Below the x-axis. So now we're going to look at the cotangent. Okay? So remember, then cotangent is flip the tangent. So this is going to be cosine over sine. So if I do like my little XY table, so we'll go 0, pi over 4, pi over 2, 3 pi over 4, pi, 3 pi over 2, 2 pi. So at 0, if we look at our unit circle, okay, the cosine is 1, the sine is 0, so this is going to be undefined. Pi over 4, the cosine and the sine are the same, so this is going to be 1. At pi over 2, the cosine is 0, the sine is 1, so 0 over 1, this is 0. 3 pi over 4, again, they're the same, but it's negative, so negative 1. At pi, we're undefined. 3 pi over 2, 0. Up to 2 pi, undefined. So at 0, I have an asymptote. At pi, I have an asymptote. At 2 pi, I have an asymptote. So all of our integral multiples of pi, we're going to have asymptotes for cotangent. So now if I plot these points, so pi over 4, okay, so pi over 4 is going to be right here, 3 pi over 4 right here. So pi over 2, I know I'm at 0, pi over 4, I was at 1, 3 pi over 4, I was at negative 1. So the cotangent is basically just like the tangent, only it's flipped. It goes the other direction. It starts out at the top and it decreases. So again, following that pattern, we can draw all of these cotangent graphs. So in this graph, I have 1, 2, 3, 4 full cycles. The domain of the cotangent, again, all real numbers, except now we're looking at integral multiples of pi. The range, negative infinity to infinity. The period, again, here the period is pi. Okay. The zeros, now we're looking at where the cosine of x equals 0. So like that pi over 2, 3 pi over 2. Vertical asymptotes at our integral multiples of pi. Increasing, the cotangent graph is never increasing. It is always decreasing. Positive above the x-axis, negative above the x-axis. Sorry, below the x-axis. So now let's talk about when we have an A and a B. So A stretches the graph vertically. The larger B corresponds to a smaller period, so the graph appears to horizontally compress the parent function. So here, to find the period for tangent or cotangent, it's going to be pi divided by B. Remember, sine and cosine were 2 pi divided by B because their period were both 2 pi. but since the period of tangent and cotangent is pi, it's pi divided by b. All right, so first one we're going to graph, y equals 2 tangent of 4x. So first we want to find the period. So pi divided by 4. So that's our new period. So then that means we're going to have new asymptotes, right? So to find our new asymptotes, take what the original asymptote was, negative pi over 2 to pi over 2. Set it equal to this, 4x. Cross multiply, solve for x. So when I cross multiply here, I get 8x equals negative pi. So x equals negative pi over 8. Here I get 8x equals pi. So x equals pi over 8. So we have vertical asymptotes that are odd multiples of pi over 8. All right, so we're going to draw 2 full cycles. Let's get a straight line going. We're going to draw 2 full cycles of this tangent function. I know that I need pi over 8. Okay, so I'm going to do a pi over 8 and a negative pi over 8. So in between my pi over 8 now, right, I know that in the middle, right, halfway between here, so negative pi over 8 to pi over 8, right, gets me a period of pi over 4. I know that in the middle of that is my 0, so then I need here and here. So halfway between 0 and pi over 8 is pi over 16. So then this would be negative pi over 16. So then I could keep going. Right? So after pi over 8, so then the next asymptote, the next odd multiple is going to be 3 pi over 8. Halfway between pi over 8 and 3 pi over 8 is 2 pi over 8, but that reduces down to pi over 4. And again, I could go the opposite direction if I wanted to. So this would be negative pi over 4, negative 3 pi over 8. So we're going to draw our asymptotes. So all the pi over 8s are our asymptotes. We had a 2 out here, right? Tangent and cotangents don't have amplitudes because amplitude is the height of the graph, right? Our tangent and cotangents, they keep going in both directions. This is just going to give me that first point. So on the tangent and cotangents where we had a 1 originally, so now it's just going to be a 2 there. So if I'm going to plot this, I have a 0 at here. So at negative pi over 16, instead of being at negative 1, I'm going to be at negative 2. At pi over 16, instead of being at positive 1, I'm going to be at positive 2 since I'm multiplying by 2. So this is what this graph looks like. So then at pi over 4, I'm a 0. So again, halfway in here. So this is going to be at positive 2, negative 2. Zero, positive 2, negative 2. So I actually gave us 3 cycles, 3 full cycles there. On our homework, we're going to have at least 2 cycles, okay? All right, so then let's go to the next one. Now we're going to graph y equals 1/2 cotangent of 3x. Again, we want to first find out what is the new period going to be. So it's pi divided by my b, which is 3. So then I need to find my new asymptotes. My original asymptotes of cotangent were at negative pi and pi. So negative pi equals, set it equal to this, 3x. Solve for x. So x equals negative pi over 3. And x equals pi over 3. So our vertical asymptotes are going to be at odd multiples of pi over 3. So again, we're going to draw this graph. Now I know at pi over 3 and at negative pi over 3, I'm going to have asymptotes. Okay? So I'm going to go ahead and draw my asymptotes in.